muchachos and brochachettes. Or cis-chachos. Today we're talking about arithmetic sequences. And I know what you're thinking. Arithmetic sequences? Don't you mean arithmetic sequences? No. So what is an arithmetic sequence? Well, what's a sequence? A sequence is a pattern. Okay? Probably the first pattern you ever learned in your entire life, other than 1, 2, 3, 4, 5, 6, is 2, 4, 6, 8, 10, 12. That is an arithmetic sequence. An arithmetic sequence is when you add the same number to get to the next number. And in the case of 2, 4, 6, 8, 10, 12, you add 2 every time. Now that 2 has a specific name, and it's called the common difference. Whatever you add to get from one number to the next in an arithmetic sequence is called a common difference, and we call it D. Now, we call each number in a sequence a term. So that's another word that we're going to use a lot that we haven't used a whole lot before. So when I look at this sequence right here, I have a term of 11, 8, 5, 2, negative 1. And it seems to get from one number to the next. I subtract 3, I subtract 3, I subtract 3, and so on and so forth. Now, the common difference is what I add to get from one number to the next. Well, we always consider it adding. So what do I add to get from 11 to 8, from 8 to 5, from 5 to 2, and so on and so forth? Well, I add negative 3. So if the common difference, or if the pattern is subtract 3, my common difference is whatever I add, which is negative 3. Okay, so we're going to have our common difference, our D is going to equal negative 3. All right? Now there's going to be two formulas that we're going to look at. The first formula we're going to look at is called the recursive formula. Okay, the recursive formula is just a way of finding out what a specific term is if I'm given like the previous term. It's kind of very, 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 very basic. Even though it doesn't look basic at all, it's very basic. If you're wondering what all of these A's and N's are, okay, the N stands for the number term in the sequence. So if I have 15 terms in a sequence, N is 15. Okay? A sub N is the specific number that I'm talking about. So if the 15th term of a sequence is 100, then A sub 15 is 100. Okay? D is the common difference. So really, for us to understand this formula, because it is kind of weird to look at, it's kind of confusing to look at with all the subscripts and stuff like that, the best way to understand it is to actually do it. So my job is to write a recursive formula for this arithmetic sequence, 4, 7, 10, 13. Right? What I'm going to do is I'm going to write out the definition of a recursive formula, which look like that. And I'm going to write out what I know. And the only thing that I know is what the common difference is. So what do I do to get from 4 to 7, from 7 to 10, from 10 to 13? I add 3, add 3, add 3. So my common difference is going to be A sub n equals A sub n minus 1 plus 3. So kind of a dumb problem if we're going to keep it 100. And really the only time you're going to use a recursive formula is if you have a previous number. So if you want the 18th term of a sequence, you're really only going to use the recursive formula if you have the 14th, or what did I say, 18th? You're going to have the 17th term. So, like in a case like this, where I have only the first 4 numbers, and I'm like, find the 18th term in this sequence, this isn't going to help me. Not at all. And that's when we're going to use the next guy, which is the explicit formula. Now, the explicit formula is more important because it contains more cursing. I'm just kidding. I'm just kidding. No cursing. No cursing. Not in my videos. Those other YouTubers, they may curse a lot, but not me. No, this is a kid-friendly YouTube channel. So what does the explicit formula look like? What do you need? What's important? Well, it has a few more things attached to it, a few more letters. You really need to know a sub 1, which is the first term in the sequence. N is the same as it was last time. D is the same as it was last time. A sub n is the same as it was last time. But if I have the first term in the sequence, right, and if I can find the common difference, and someone's like, find the 23rd term in the sequence. Like if I'm doing 2, 4, 6, 8, ... and someone's like, find the 24th term in that sequence, I don't have to be like, okay, fine, 2, 4, 6, 8, 10, 12, blah, 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 and keep going. I don't have to do all that. I have enough information to use that formula, plug it in, and get myself an answer. Okay, so let's see. Let's see if that's what we have directly in front of us. Find the 12th term in the sequence, 4, 7, 10, 13, blah, 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 blah. All right? Well, what I said last time is the recursive formula is only helpful if I have, in this case, the 11th term in the sequence, which I don't. The explicit formula is useful if I'm trying to find some number way the heck out here, which is what I want to do. So I'm going to write the equation in its full. A sub n equals a sub 1 plus n minus 1 times the common difference. I'm going to find out what I can find out, okay, and then plug in everything I can. I care about the 12th term in the sequence, so n is 12. Okay. It looks like my first term, a sub 1, is 4. And then I have 4, 7, 10, 13. Looks like I'm adding 3 every time. My job is to find the 12th term. So I need to find a sub 12. Do I have the first term? Yup. Do I know what n is? Yup. Do I have 1? Yep. Do I have d? It's 3. I can move on. So I need a sub 12, the 12th term. That's going to equal a sub 1, which is 4, plus parentheses, n, which is 12, minus 1, times the common difference, which is 3. And now it's just a good old-fashioned PEMDAS. 4 plus 11 times 3. PEMDAS says you always do stuff inside the parentheses first. PEMDAS says you always do multiplication, division before you add, subtract. And then you just add them numbers. And there you go. So would it have been the end of the world to go 4, 7, 10, 13, 16, blah, 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 all the way up to 12? Nah. No, not really. But this is a lot, maybe faster, and it's a whole lot more convenient if I were to ask you to find the 83rd term or something crazy like that. Because I can count up to 12 just fine, but I really don't want to have to count up to 83 by threes using different numbers if I don't have to. Rather not. Big no thank you on that one. The first term of an arithmetic sequence is 9, and the sixth term is negative 6. Find the fourth term. Okay. The first term of an arithmetic sequence is 9. And the sixth term is negative 6. Find the fourth term. Okay, so let me write out my equation. I have a sub n equals a sub 1 plus n minus 1 times d. Let's plug in what I know. Right now, I'm not going to focus on that. I'm just going to put a squiggly there. I'll get to it later. The first term is 9, so a sub 1 is 9. The sixth term is negative 6, so a sub n is negative 6, and it's the sixth term, so n is regular 6. Alright, so a sub n is negative 6. That equals a sub 1, which was what? 9, all sloppy over there, plus parentheses 6 minus 1, and I don't know the common difference. Kind of working backwards here. All right, I can handle this. I know Algebra 1. 9 plus 6 minus 1 is 5, so 5D. Right now it's just a two-step equation. Subtract 9 from both sides, subtract 9 from both sides, cross U out, that gives you negative 15 equals 5D. Divide both sides by 5, D equals negative 3. Yuck! Done? Nope. See, I have to use this information to do this exact same thing again and now find the fourth term. So let me erase this. Now I need to find the fourth term. So all this information I'm just going to erase for a moment. Okay, I need to find the fourth term. Let's get a different color. The first term of an arithmetic sequence is 9. I still care about the first term. The sixth term is negative 6. Probably don't need that because now I need the fourth term. So n is now 4 and d is negative 3. So if I were to use the same exact equation that I did over here, right? A sub n, and I care about the fourth term, so a sub... Okay. A sub n is a sub 4 in this case, equals a sub 1, which is 9 like it was last time, plus parentheses n, which is 4, minus 1 times the common difference, which I just found out to be negative 3. So let me put parentheses negative 3. According to PEMDAS, I do stuff inside the parentheses first. 4 minus 3 is regular. I'm sorry, 4 minus 1 is regular 3. Look at me accidentally working ahead. Negative 3 times regular 3 is negative 9, and a number plus its opposite is 0. So the fourth term in this sequence is 0. Interesting. So that was a weird one. We had to kind of go backwards a little bit and do some interesting stuff. But that's arithmetic sequence. Okay? We learned two formulas. First one, not that important. The second one, much more important. And you're going to really want it when you have to find like an 800th term in a sequence. That's not stuff that you'll do until like, Algebra 2 or pre-calc or something like that. Okay? Okay, that was great. Bye.